For this video, I want to talk about the glial cells. We spend a lot of time talking about neurons, and rightfully so. Neurons do the incredible work of the nervous system. They generate action potentials to communicate. They do the computation that results in the mind and everything that that is who you are. However, neurons could not do all the work that they need to do if not for the glial cells. Oops. Okay, sorry, the glial cells. Today we're going to talk about astrocytes, oligodendrocytes, Schwann cells, and microglia. These glial cells are incredibly important, not just in their function, just in their sheer numbers. Neurons making up just a minority of the total cells in your nervous system, the vast majority being made up of the glial cells. Now, glial relates to glue, the idea that these cells keep the nervous system sort of together and functioning and working as a unit. Let's start with astrocytes. I'll talk about three main jobs that astrocytes do. First, they are part of what gives structure to our brain. Uh, the brain as it is with a healthy astrocyte system is still rather mushy and soft. Without the astrocytes, it would be completely untenable. It would be just complete goo. So astrocytes give some sort of a structure to your brain. The way I think of this is like the frame of a building. You need the frame in order for all the important components like the plumbing and the electrical, the heating ducts and everything to have something to hold on to. And astrocytes have a function similar to that. The second is what's illustrated in this slide here. Here's an astrocyte, this purple asterisk star looking cell. You see it has many, many arms. It's drawn here among four neurons and a blood vessel. You see a lot of its arms go and connect to neurons. Some of its arms go and connect to blood vessels. Now, it turns out the situation we have in our nervous system is that blood supply is not delivered directly to neurons. Rather, as you can see here, the astrocyte is a middleman, taking nutrients, energy from the blood supply, delivering it to uh, your neurons. Now, that's very helpful, but on top of that, the astrocyte has a limited battery capacity where it can where it can store, sorry, not sort, store a certain amount of energy for use later. That comes in handy in a couple of situations. One rather unusual, and one example I want to give you tells you just how important this is to moment brain functioning. So first, imagine you're doing some benign activity like driving to school when we used to do that. Uh, you were coming, and let's say a child or a puppy ran across the street right in front of your car. You must react immediately. Now, this is important. In order for you to react immediately, that requires a tremendous increase in levels of neural activity. In order to have increased neural activity, you're going to have increased energy delivered to your neurons. This comes by way of the blood. Blood comes to your neurons by way of the heart. But the heart takes, or the circulatory system takes 6 to 9 seconds before it can really increase blood supply to any particular part of the brain. This is a problem. You don't have 6 seconds to react if a child runs in front of your car. You must react immediately. And you can do this because your astrocytes can give a surge of oxygen and glucose that your neurons need to do that work. Then, as blood flow increases, uh, astrocytes will replenish and everything stabilizes. But that's an unusual situation. But any moment to moment boost in output, behavior output, thought output, concentration, attention, or if we were in class and I made eye contact with you, that would immediately require a boost in neural activity. And in class, what I normally do is I ask someone what their name is, someone who I haven't been looking at. That usually the student is in a sort of a calm, sometimes zoned out state, but they're just sitting there taking the lecture. And I suddenly ask them a question. Well, that requires their different parts of their brain to activate to increase their activity level significantly in order for them to remember who they are and to activate the muscles required for speech. That requires a lot of energy. And if you don't have um, astrocytes, you cannot tell me what your name is for 6 to 9 seconds. I mean, you'd never be able to because, as you can see, you wouldn't be getting blood anyway, and your neurons would die. This is just absolutely critical. So I think you see why uh, we say that these glial cells, even though they're not doing computation like neurons, they are absolutely critical in supporting the work of neurons. All right, the third function of astrocytes. Here I use an analogy of tow trucks with respect to the LA freeway system. As happens every day, there are accidents, stalled vehicles, debris on the highways, and we need tow trucks to come to the area to clean up the problem. Well, similarly, in our nervous system, we have cellular injury, cellular death, debris that needs to be cleaned up. This debris, if it does not get cleaned up and removed, can lead to severe disruption in neural functions. Just like if you leave a bunch of car accidents on the freeways, traffic's going to grind to a halt. Well, thankfully, we have astrocytes and tow trucks that go to the problem site and clean up the mess, whatever it is. To give you an appreciation for how important this is, Alzheimer's disease, one of the worst diseases to strike humans, anyone who's seen Alzheimer's, I think, would agree, is in essence, or in one way of looking at the disease, a buildup of debris throughout the brain. And this debris smothers the work of neurons, damages these neurons, leads to their death. The death of neurons, guess what, causes more debris to pile up, and it's a snowball effect. But in a healthy, normal, young brain, uh, injuries like that are taken care of by astrocytes.